10th question. AX, A2Y and AZ are sparingly soluble salts in water having KSP values of 1.6 into 10 to the power minus 9, 3.2 into 10 to the power minus 11 and 9 into 10 to the power minus 12 respectively at 25 degrees Celsius. Which of the following shows the order of the three saturated solutions of these salts in decreasing concentration of cation A plus at 25 degrees Celsius? Let's write down the ice method for all the three compounds to have a saturated solution. So let's write down for the AX solids get dissolved in water to give a plus and X minus having saturated solution. If you write down the ice method, let's assume we have n amount of AX initially here. We don't actually need that value, but let's assume for the moment the reacted or the dissolved amount. The dissolved amount can be taken as, let's say, simple A here. Now according to the stoichiometry, it's 1:1:1. The amount of A plus here will be A, X minus will also be A. So at equilibrium we have n minus A here, A and A for the A plus and X minus. Okay, let's go to the next compound. That will be A2Y. A2Y is a 3-ion system. When it gets dissolved in water to form a saturated solution, it will form A plus cations and Y2 minus cations. To balance it, we have to put 2A here. If we write the ice method, let's say initial amount is the same N here. The dissolved amount will be B here. It's different than the A. We don't know actually. So let's take it as B. So according to the stoichiometry, it's 1:2:1. 2B is the amount of A plus that is generated here. 2B, Y amount will be B. So at equilibrium, we have N minus B, 2B and B. The third compound, it's AZ. AZ solid gets dissolved in water to form a saturated solution. And in the saturated solution, there will be A plus and Z minus. Now, since this is an MCQ question, I am not writing these aqueous things for the A plus and the other anions, but in the essay or structured essay questions, you have to write the physical states, otherwise you will lose some marks. Right, let's write down the ice method for this. The initial N amount, let's say C amount is dissociated from here. Sorry, not dissociated, C amount is dissolved from here. Now according to the stoichiometry, it's 1:1:1. C amount of A plus will be generated and C amount of Z minus will also be generated. Therefore at equilibrium, this will be N minus C, this will be C and C. Okay, now let's substitute these values to the KSP value, the KSP expression. KSP equals A plus into X minus. Now the KSP value of this compound is 1.6 into 10 to the power minus 9 equals A concentration at equilibrium is simple A, X minus is also simple A, so we can write A squared. Now A squared is equal to 16 into 10 to the power minus 10. I just rearrange this value so that I can take the square root easily. So A value will be 4 into 10 to the power minus 5 here. Since the A plus concentration is simple A plus concentration is equal to 4 into 10 to the power minus 5 moles per decimeter cube. Okay, let's go for the second compound. KSP equals A plus concentration squared into Y2 minus concentration. KSP value is 3.2 into 10 to the power minus 11 equals 2B. Now A plus concentration at equilibrium is 2B and the Y2 minus concentration is B. Now this should be squared here. Let's convert this into a easily simplifiable value. 10 to the power minus 12. This is 4b cubed. Now this gets cancelled off, it becomes 8. So b cubed will be 8 into 10 to the power minus 12. Now taking the cubic root of both sides will give you the answer. B equals, now 8 is the cube of 2, therefore cubic root of 8 will be 2 into 10 to the power minus 12. Since A plus concentration is equal to 2B, the A plus concentration here will be the 2 times of this one. Therefore 4 into 10 to the power minus 12 moles per decimeter cube. The last one, AZ compound. KSP equals A plus concentration into Z minus concentration. KSP value is 9 into 10 to the power minus 12. A plus concentration is C at equilibrium. Therefore C here, so C squared. The C value will be 3 into 10 to the power minus 6. Since A plus concentration is equal to C, A plus in this solution will be equal to 3 into 10 to the power minus 6 moles per decimeter cube. Now all of these values are in scientific notation, so just look at the 10 to the power values. Sorry, I made a mistake here. This is not 12, it should be 6. Please be informed. The square root, the cubic, sorry, not 6 actually, it's the cubic root of 10 to the power minus 2 into 10 to the minus 12. So it's this value is not 10 to the power minus 12. It is actually 2 into 10 to the power minus 4 here. So this is also 4. Just excuse me for this mistake. When you take the cubic root of 8 is 2. The cubic root of 10 to the power minus 12 is 10 to the power minus 4. This power gets divided by 3 here, and this is multiplied by 2 because of this situation. So this is 10 to the power minus 4 here. This is 10 to the power minus 6. Now when you look at these 10 to the power minus values, we can see 10 to the power minus 4 has the highest value, 10 to the power minus 4. So A plus concentration obtained from A to Y will be the highest. Then the highest value will be 10 to the power minus 5. Therefore it will be AX. Then the last compound, AZ. So this is how the A plus concentration decreases. Therefore the answer will be the second one. Alright, sorry about the calculation mistake I made here. I didn't want to recorrect this and make a new video about this. Just you can see that everyone gets mistakes sometimes. So let's go to the next question.